Hello, today's lesson we are talking about spheres. We're going to do surface area and volume. Before we get started on that, this is our last new lesson for the school year. And so I want to remind you that next week you're going to do a skills assessment. And then we have, after that, the last day of class. We will start both classes next week with a Zoom meeting at the beginning of class. So make sure you come to those Zoom meetings at the beginning of class, both periods next week. Okay? I'll make sure it's on Schoology and on the Google Doc. All right, let's get started. So what is a sphere? So if you remember, a circle is a set of points that are all equidistant from one point. Well, a sphere is the same thing. The only difference is a circle is in 2 space and a sphere is in 3 space. Okay, so a sphere is the set of all points that are equidistant from one point, okay, in 3 dimensions. And that one point we talk about, that's called the center. And that equidistant, that distance, is my radius. Okay, so if you look at my pictures here, we can see my center is right in the middle of that sphere. The radius is the distance from the center to the edge of the sphere. A chord is going to be a segment that is going to go from 2 points on the surface of your sphere, and it's not going to go through the center, okay? So the chord does not go through center. Two other terms you're going to hear about a lot when we talk about spheres is the great circle. So a great circle is going to be a cross section of my sphere that goes through the center. Okay, so it's a cross section through the center of the sphere. Okay, and all of my great circles are going to be congruent. They're all going to be congruent to each other. Okay, and if you think about the globe, we have a whole bunch. The equator is a great example of a great circle. Okay, so the equator and all of the longitudes, the ones that go from the North Pole to the South Pole, all of those are also great circles. And fun fact, if you have 2 cities on my globe, the closest distance between them, the flight patterns, are always going to go on great circles. So that's kind of an interesting thing. So whenever you fly, which I know you're not doing right now because, we're all stuck at home, but if you're flying, the flight patterns are always great circles. So cool. A great circle will divide your sphere into 2 congruent halves, and those halves are called hemispheres. So hemisphere is 2 halves of the sphere created by a great circle. All right. Our first theorem is the surface area of a sphere, and the formula for surface area is 4 pi r squared. And if you we're not proving any of the theorems, but a way to kind of think about it is think about a baseball. If you were to take apart a baseball and look at the leather coverings, you see that you have 4 circle-like ends. They're not quite circles, but if you were to put a circle on the end, there is this space. It's not quite a circle, but so there's this extra space here that if I did put a circle there, and that extra space would fill in this. So if I take the area of those 4 circles, and remember the area of one circle is pi r squared, and I take 4 of them, then I'm going to have the surface area of that sphere. All right, example. Find the surface area of the sphere. Okay, our sphere here has a radius of 8 inches. And so when I do this one, hold on, I gotta find my calculator. There it is. Okay, so we'll start with our formula. 4 pi r squared. So surface area equals 4 times pi times 8 squared. So 64 times 4 is 256. So I get 256 pi, which is my exact answer. Okay, because it contains all of the decimals. And then when I plug it in to get an approximation, remember to use your pi button. we get 804.25, and my units here are square inches. Okay, our next example. So go ahead, pause, try the next one on your own, and then press play. It says that the surface area of a sphere is, oops, I forgot to math that. So that should be 20.25 pi is what it should say. Square centimeters. What is the diameter of the sphere? Remember, diameter is twice the radius. So if I find the radius, I can then find the diameter. Okay, so let's start with my surface area formula. So surface area equals 4 pi r squared. And they give me that the surface area is 20.25 pi. And that's going to equal 4 pi r squared. I'm going to divide both sides by 4 and pi to get r squared by itself. So the pi's will cancel, the 4's will cancel, and 20.25 divided by 4 is, oh my gosh, I need my calculator, is 5.0625, and that equals r squared. I'm going to take the square root of that, and so then I get that the radius is 2.25. So then my diameter, remember, is twice the radius. So my diameter is going to be 4.5, and my units here are centimeters. Great. All right, our last theorem of the year. This is very exciting. Last theorem of the year, volume of a sphere. The volume of a sphere is 4/3 pi r cubed. How they prove this in your book, if you're interested, you can look in your book. There's a PDF on Schoology, if you've ever looked. But anyways, they take a whole bunch of little pyramids and they say, hey, look, I can look at a little tiny pyramid here. And they look at all of them and then they add them all up, and that's how they get to the formula. So if you're interested in that, you go check it out, but you don't have to. Okay, we got two examples on volume. The first one is find the volume of the soccer ball that has a diameter of 9 inches. Okay, so let's look at this soccer ball. So I'm going to start with my formula. Volume equals 4/3 pi r cubed. And if the diameter is 9 inches, that means my radius is 4.5 inches. So volume equals 4/3 pi times 4.5 cubed. I'm just going to plug that into my calculator just as it is, okay? So make sure that you do 4 divided by 3 in parentheses, and then do your pi button, and then you can do 4.5 to the third in parentheses, okay? And your calculator knows order of operations. Your calculators are very smart. And we are going to get about, I should erase my equal sign because it's approximation, 381.70, and we're doing volumes. My units are cubic, and I have a radius of inches, so cubic inches. Okay. Next, find the volume of the composite figure below. So the word composite just means that we have 2 or more figures that are put together into one figure. Okay, so if I look at this, I have a cylinder on the outside, and then in that cylinder, we've kind of taken out a spherical chunk, a hemisphere. Okay, so let's see here. So we need, the cylinder is going to be the outside, so we're going to do volume of cylinder. And then we'll also need to calculate the volume of the hemisphere. Okay, so volume of a cylinder. Write down the formula. Let's see if you remember it. So the volume of the cylinder, remember, is going to be pi r squared times h. So if I plug in all of the pieces there, pi, my radius of the cylinder is 2, and my height is also 2. So I get pi times 4 times 2, so I have 8 pi. Okay, and then the volume of the hemisphere, well, I want 1/2 of the entire circle, which we know is 4/3 pi r cubed. So that's 1/2 times 4/3 times pi, and then 2 cubed. And 2 cubed is 8. So then I'm going to get 8 times 4. Let's see here. How can I do this? A 2 here, 2 here. Aha. So this 2 will cancel with here, and I get a 2. And so then I have 8 times 2, 16/3 pi. Did I do that wrong? 1/2, 2 cubed. How did I mess up? Yeah, 16/3 pi. I did not mess up. Okay, great. Yep. Okay, so now let's think about this. So the cylinder is on the outside and the hemisphere is on the inside. So I am going to get 8 pi minus 16/3 pi. Okay, think about pi like a variable a little bit. Okay, so I now want to make this with common denominators. So my total volume. So if I make those common denominators, I get 24/3 pi minus 16/3 pi. So my final answer is going to be 8/3 pi. And my units here are inches cubed. Okay, and if you want to plug that into your calculator to get an approximate, that is going to be about 8.38 cubic inches. Great. So go ahead and do the homework on spheres.